If you recall, in the last two lectures we had seen that how we can interface devices like relays, DC motors etc., to the microcontroller, and we can do some kind of a control, and also we can sense the values and so on. Now, in this experiment that we shall be showing you in this lecture, we shall be trying to demonstrate that not only one device or one sensor, the microcontroller is powerful enough to control multiple devices at the same time. So, this particular lecture is titled "Some experiment with multiple sensors and relays." Now, here we shall basically be looking at how to interface multiple such devices, multiple sensors and multiple output devices, and we shall be demonstrate this kind of an interfacing to you. Let us talk about the experiment first. Now, in this experiment, as I said, we shall be interfacing multiple sensors and multiple output devices. Specifically, the input devices that we shall be looking at are LDR for sensing ambient light and a temperature sensor for sensing the temperature of the environment. Now, the output devices that we shall be interfacing are one relay circuit that will again be driving that bulb as we have seen in the earlier lecture, and a speaker. Now, the kind of an environment that we are trying to show you is, suppose first one is the one that we have already shown earlier. Depending on the ambient light, you can automatically switch on or switch off a bulb through a relay. And secondly, there can be something like a fire alarm system. There will be a system which will be sensing the temperature, and whenever the temperature crosses a certain threshold, preset threshold, there will be an alarm that will be sounded, and for that alarm we have interfaced a speaker circuit. Okay. So, we shall be showing you how you can write a code for that. Okay. And as I had mentioned, the example is realistic enough so that you can have an automated light on off system and an automated security system where you are sensing some kind of fire occurrence by looking at the temperature level. Okay. So, specifically in this experiment, as I said, we will be interfacing a relay, a speaker, an LDR and a LM35. And the specific ports that we will be using, the relay will be driven by digital port line D3. The speaker will be interfaced from port line D5. The LDR circuit, the output of it will be connected to the analog input A1, and the LM35 sensor will be connected to analog input A0. Now, if the ambient light input falls below a threshold, the bulb will turn on, and as I said, whenever the temperature crosses a threshold, the alarm will sound. Of course, in this experiment we will not be able to show you the variation in temperature, but at least the circuits and the way it works, you can understand that. Let us look at the connection diagram first. This is your STM board, and this relay circuit is the same as we had shown earlier. This is the same circuit, and on one side we have just an LDR circuit which will be sensing the ambient light. There will be a resistance divider. The output is connected to the analog port line A1. On the other side, you have the LM35 temperature sensor, which will be generating the output on analog input line A0. And for alarm, you have a speaker which is connected to D5, which is a PWM controlled output port. So, whenever the temperature crosses a threshold, this speaker will be sounded, and whenever the light falls below a level, this relay will be activated so that the light turns on. Let us look at the program logic first, then we shall be showing you the code. The steps as shown here will be running in a repetitive loop. What we will be doing, I mean essentially this is not the correct C code, just the steps I am trying to show. First we will have to check the value on the analog input line A0. If it exceeds the threshold level for the light that you are trying to sense, you turn off the relay, that means you have sufficient light, otherwise turn on the relay, that means the bulb will glow. After that you check similar thing for the temperature. If the value on port line A1, analog port line A1 is exceeding some threshold level, then you play a tone on the speaker which will indicate some alarm, but if it is not, there will be no PWM tone, that means you do not play a tone. Okay. Now, let us look at the program. The program will start like this. So, you are defining a PW out line on D3 which you call as bulb, then another PWM out on D6 which you call speaker, and there will be two analog inputs, one on A1, A0 corresponding to LDR and LM35. So, these are the names we have given: bulb, speaker, LDR and LM35, and some variables we have defined: light, temperature for calculating the analog inputs, and light value and T value, some temporary we have temperature value, we have used two variables integer. And for activating the bulb, we have assumed that we are using 50 hertz PWM 0.02, which means 20 milliseconds, right. 20 millisecond means 50 hertz, 50 times per second. And for speaker, we have set a period of 3 milliseconds. We have called the function period ms, where we can specify the time in milliseconds. 3 millisecond means approximately 333 hertz of frequency will be played on the speaker. Okay. Then let us come to the rest of the main function. So, in a repetitive while loop, we are checking the light here, we are checking the temperature here. In the light, we are using the analog input function LDR read, then you are multiplying it by a scale factor just like in the program that we showed earlier. If it exceeds some threshold value, we turn off the light because there is sufficient light. If not, you turn on the light. So, either the duty cycle is 0.0 or duty cycle is 1.0. Well, instead of write, you can also write bulb equal to 0.0, bulb equal to 1.0, they will mean the same thing. Here I have shown that way. Similarly, for the temperature, you are reading the temperature, you are again multiplying it by some scale factor, here I am using 1000, and some threshold which again can be found through experimentation, depends on the temperature where you want to start the alarm. So, you set that accordingly, and if it is so, you play a continuous note on the speaker, 50% duty cycle, that means there will be a continuous tone of 333 hertz with 50% duty cycle will be played, but otherwise if not, then you set the duty cycle to 0. Now, this line is actually not needed, this line you can also omit, this is not required, because once you set the duty cycle to 0, the period does not matter. Okay. So, this line also you can omit. This is how the program works. Let us look at the demonstration now. So, this is the code. This line we can omit, we do not need this. So, let us compile this code. So, we compile it. we save it, copy and paste. Now, let us come to this circuit now. Now, see, we have used that same light interfacing circuitry as we had shown earlier, a relay, a bulb with a switch connected to mains, and we have used the same LDR circuitry. You see, if LDR is interrupted, the light is glowing. If LDR is interrupted, the light will glow, you see. If it is released, again light will, and here you have this LM35 setting here. If LM35 temperature exceeds the threshold, but as I told you, here I cannot show you the exact temperature rise because we do not have any heater or anything here in this setup, but if it is, the voltage is high enough, then there will be an alarm tone. Yeah, you see, the temperature has just increased beyond a level and this alarm has started to rise. So, I am just pressing with my finger, so that the temperature increases a little bit. So, if you had a heater, you can show it in a very clear way. Yeah, you see, there is an alarm sounding. Yeah. So, you see, this is alarm is sounding because it is just crossing threshold, but if we can heat it a little further, then there will be a very clear sound that will be coming. And the LDR, you see, LDR, if I press, darkness, light is glowing, if I release, light is switched off. Again, if you press the LDR, light is glowing, again releasing, light is off. So, in this experiment, what we have seen is that we can have multiple devices. See, means when you talk about home automation, in your home there can be so many kind of devices connected. There can be not one, two, nowadays there can be tens or even hundreds of devices we talk about. Now, these microcontrollers are powerful enough such that a single such device will be able to control the entire thing. The only thing is that you have to write your program in such a way. Some of the devices will be sending the inputs in interrupt driven mode. Some of the devices you can just read them one by one, just in this experiment as I have shown. You read the light, read the temperature in a loop one by one. So, it depends on the type of devices, the way they are sending you the inputs. Okay. So, we shall be seeing more demonstrations on these in our later lectures, where you will also be looking at some ways of communication, how the device can communicate with the outside world. We have so far only talked about interfacing with sensors and output devices. Okay. So, these we shall be seeing in our next lectures. Thank you.